Hello. I will try to demonstrate what I just finished to program with a lot of effort. How to store in hard disk a continuation, a Haskell continuation, and continue it at will from scratch in a after a call restart. To see what I mean, I have this sequence of commands. Basically, this is a option, which is a kind of input from the keyboard, which is wait for a certain option, which is broken, which start and continue the rest of the computation using transient, a transient primitive like this. This option is logged in after asynchronization is logged. Every input with every result with this command is logged in the corresponding location in the file system. And after the option is triggered, then I store other variables in the login store. I have two continuation. I set 2 points that can be called after a call start and also, of course after a warn start. This is a new primitive. In fact, is this one which is set count. I will probably change the names and things like that. What this perform is to take note of that point and store it separately from the rest of the log, and in a way that can be called in a call restart. So what I do is just print the identifier of the continuation, which is this. I also has another identifier. The second is the location it depends on the location in the code, and the first one I only use 0, but is in fact it can change so that I can have different values for different continuations at the same point in the execution. This parameter is called the session number, and this is the closure number. Later we will see that it can be entered by input, so that I can, after a call start, call any of them, any of the two of them that I have here, one here and one here. So I have code that is printed and stored after each one of these two continuations. I also can save the state of execution using a library that I developed previously, so that the logs are synchronized with the permanent storage. And finally, I have the restore part, which is ask for two parameters, the two parameters that identify a continuation, that I printed here, the session and the closure. Okay, session and closure. And once I have the session and the closure, I can invoke with this command the restoration and execution of that continuation. And the three options are here, composed in after the main. First, I use this, which is a temporal name for a command that store everything, store the chain of continuation. Let's say that this continuation builds from this, and this continuation builds from this previous one. So it's registered for a continuation referred to the further continuations. So that when I invoke this and this is active, I don't restore the whole state of the computation, but I build from this point, and with the log I recreate the state of computation up to this point, so that I can continue normally as a normal program. Let's run this program and we'll see what happens. First, I execute, delete the cache. The first execution, compile first. So this is redundant. Okay. Okay, this is here is the three options. This one are default in any transient program, but this one is the three new options that I created in this program. So at first I execute normally the program, this option, which will execute everything until the end. So print hello, it displays the first continuation, print world, and the second continuation, and hi. Hello, continuation, world, continuation, hi. And that's all. So I save the state, and I can see that there is something here in the cache. This is the basic base continuation, which is created here. This one is the second one, which has been generated by the first point, and this one is the second one generated at this point. So I can, of course, invoke any one of them using the restore here. Sorry, restore. Restore is this option. Okay, this option here. So I can call rest 3 or and what I do is just print the continuation, which is after this second one, simply print this result. I can invoke the previous one, which is this one. and this print word and I because word is after this the first one. So far so good, but what is new in this and what I want to show you is that I can terminate the program and start it again. At this moment, because I have a program state stored, I can restore right from any of them because I have the data stored for each one of these continuations. So I can restore the second one. One these are entry parameters, and I print it prints both of them because when the restore it restore the second it restore first the first one because it's in the path of execution. So it restore and print the continuation, everything that is after it. Execute the code that is after it, which is simply get I from the log from the hard disk and print the value that is demanded to print here. So that's of course I can run the other and do what it means to do. The reason for having two parameters to identify a continuation is because there might be many different continuation for the same base continuation. So I can call it a continuation many times, and I can store each one of these states. If I use the same identifier in the identifier, of course the next execution will update the previous state, and it will be lost, and only will be active the new one. So because this program is intended to be used, this functionality is intended to be used with for workflows in which different users can invoke a continuation and create their own private states beneath a session state. Of course, well, you can like to see what is in these files. This is, for example, the second one. It contains a session number, a reference to the previous continuation, in this case is this one, and a tree of logins which contains the incremental log of the execution, and this is something an index to the end of the log, the closure, which correspond to the continuation. So I hope that you understood what I mean, and Thank you very much.